This lesson will create our background surface, which will be a list of images, and we'll move through them one by one in an ordered fashion. Now, just for illustration purposes, I've sped up the timer so we can see it's kind of almost flashing through the images. Now let's take a look at our folder structure. We have our lesson 1 here with our current files. We have character folder, which is empty, our audio for our music so far, and our images within. We have a backgrounds folder. Then we have our menu folder for the menu. Now, if we go within our image folder, we can see we have a backgrounds folder, and within it, here we will store all our images for the background. Now you'll notice they're a bit more square shaped. They're not exactly the same shape as our screen size. So we'll have to stretch them and fit them perfectly. Now I'm quickly going to create a new folder for lesson 2. And we're going to put lesson 1 and 2 within this other new folder, game folder. So this game folder will contain all our lessons for the future for this game. Now let's open our lesson within the game folder. Let's see, we have lesson 1 currently. Let's copy this and just rename it lesson 2. And then let's start working within lesson 2. Now within this lesson 2 folder, let's create a background module. So just a Python file, and we'll import this. This module will keep track of all background needs we'll have. Now let's import Pygame within this background file. I'm just going to add a comment because I've got some dependencies, collisions for my editor. You can ignore this. Now within our folder structure, we can see we have a list of images. So why not use this and just store it within a list? So each image will be within inside this list, and we can just go through them one by one. So when we start our game, we have this menu surface, and we have 3 button surfaces that are displayed afterwards. Because if we display the buttons beforehand, we won't see them. The drawing order matters. Now all 4 these surfaces, we draw on this game window. Because remember, the game window represents the display, the window the user sees in the end product, the actual game. So when we press play, we remove these 4 surfaces, and we enter now to our game window and main game surface. So now we're going to draw surfaces that are within the game itself. The first one is obviously going to be the main background. Now, the reason we draw the main background first should be obvious, but let's go over it. So the draw order in all games matter. Doesn't matter the type, if it's 3D or it's 2D, that draw order matters. Now, it's obviously much more complex and different in 3D, but the draw order always matters. So if you draw the background later on and you have other objects, what's going to happen is you simply won't see them. They'll be there, they'll interact if the logic is correct, but the user will be flustered because he won't know what the hell is hitting him. So if we move this to the front, so we draw it later on, you can see you can draw something. Now let's remove that character. So our background is just going to be a list of images that we're going to display on a timer. So in the previous lesson, you might have thought this black background surface is just a placeholder for our game, but it's not. It actually serves a vital role. So whenever we draw something and we move it, there's going to be a smearing effect that happens, which I'll show you later on. But for now, we'll just have to understand that every time we draw an image within the main game loop, We draw the black surface first. So we draw the black surface on the screen. And then the next thing we draw is whatever we want to show, the game window, the game itself. So the background in this case. And then let's say we have characters, then we draw the characters. Let's say we have effects, then we draw the effects, and so on. Now, every frame, so our game runs 60 frames. So every frame we're drawing the black background first, and then we're drawing this. So it's not just every time we switch between backgrounds, but every single frame. So the quick answer for you, if you're interested, is just to prevent smearing. So later on, we'll see this effect in action. So these backgrounds will be shown one by one. So we'll have them in a list. We'll just go through our list one by one. We'll increment the index of the list to show the next image. If we're at the end, we'll just start from the first item again. If we are playing the game, and let's say we died on this background and we start again, we don't want to continue to the next one. We want to reset the image to the first one. So we have a clear order of which background always starts first when the game launches. Now we want to load our images. So let's use a for loop to go through our images. So as a full file name in a sorted list. So the names of our images must be sorted as well. We'll check for that listing directory. So we'll go through our directory using the operating system, and we'll return this string value. Now let's import from the operating system that listing directory. Now this OS module we're importing is built into Pygame itself. You don't have to install it somehow. So this listing directory is just a function from this module that we're going to import. And this allows us to go through our directory and check our folder for images. So we're going to check this backgrounds path. I believe it's going to be IMG first folder and then backgrounds folder. We'll change that slightly later on. And let's check if our individual files or individual images ends with that .png. Are they PNG format? Now let's load our image into memory. We'll create a correct filing system path. We'll use that path.join from the operating system module. Now we'll give it a path of our file. We'll add that file name for our for loop. So for each one, and then we'll convert it. So you can use convert alpha, or you can just use normal convert. So let's also import our path from the operating system module. So using convert, we just transform the image format to the same pixel format as the display itself. Now let's transform and scale our image to the correct size we want. So what are we going to scale? That image. Now we're going to get the size from our config file. So we can import our entire config file. We don't have to import everything we want everywhere because our config file is relatively small. So even though it's slightly wasting memory and slightly more, let's say, process intensive, it's worth it unless your game is exceptionally slow or buggy. Then I would say you have bigger problems. That's why we always keep the config file relatively small. So we can easily just import it and get what we want. But other things like modules from Python itself will pick and choose what we want sometimes. And from that config file, we'll get the screen width and the screen height, which is the resolution of the screen, width and its height. And then at the end, we just append each image to our list. So our loop iterates. Each time it's an iteration of the loop, we save that image we're currently loading into memory. We add it to our list. Let's put all our files just in one view so it's easier to see the code that's going on the screen. Slightly change our code flow to make it a little bit more robust. So we can see here, here's the old version of the code we have currently, but we'll slightly modify our code to work in a similar fashion, not exactly the same. So now we'll just check if our file name is not PNG format. Just add this continue, so we'll just skip it before any error could ever occur. So this will check for format issues. These are not PNG. We'll use lower to make it case insensitive, so it can be a, how can I say, capital letter PNG as well. So now we look at our code that can fail. So we'll wrap it in this try. So just like before, same exact code, we'll try to load it into memory. And this time, we'll just use normal convert. So convert alpha is only needed when we want the opacity values. This is going to be the first background. There's nothing behind it. So opacity, if anything, can actually hurt you here. If you have some opacity, you could show the black screen, for example, or whatever. So I would not recommend it. So then we'll also transform it just like prior. This is also a quite effective way of scaling because it only happens once on load. So when we load it to memory, so only once per image, not every frame and continuously. So pretty much cannot be more optimized than this really with Pygame. So now after we tried and we failed somehow, we check for our exceptions. Now we don't just want to allow any exception. Like sometimes you want to, sometimes you don't. And we want to specifically check for Pygame errors. So an error built into the Pygame module or the library specifically. And then here we have a different file within it. Or, so we have a operating system folder as well here. So we're using the operating system and we're using Pygame. So we're only going to allow those two type of errors. So operating system error and a Pygame error, SE for error or exception in this case. Then we'll print, hey, we're skipping a background image, and then we'll print file name and the error. And then we'll just continue. If this is not the case, like previously we did, we just append this image for each iteration to our list. Now let's create our settings. So we'll have our frame index, which will track the frame we're currently on. We'll have this last swap time, and then we'll have this duration. So basically how long each image will last and when should the next image come in, which is 60 seconds in this case. 1,000 milliseconds is a second. So we have 60,000 milliseconds here. Pygame tends to generally work in milliseconds. Now we'll create this function that will update our background. So here we have our frame index, which is just an integer that keeps track of the current image within our list we are in. So the current frame. We have our last swap time, which is the last time we show the image or we swapped. And then we have our frame duration, which is how long between each swap of an image or each frame. Now we just have a basic function because all we're really doing is showing an image. And when it's time to show the next image, we show the next image within the list. And there's nothing really fancy going on. Now, if you have a more complex background, I might recommend instead of using like global variables and just a function, you could just use a class and you can use encapsulation for those variables to keep it more secure and more robust. But in our case, this is definitely not needed. Now we have this last swap time here. Now we want to make sure that this is within milliseconds so we can compare the same value. So our frame duration is in milliseconds. 1,000 milliseconds is a second. So we have 60,000 milliseconds here, 60 seconds. So to make sure we compare them equally, just delta time will represent seconds here and multiply it by 1,000 to get it within milliseconds. So after this, we compare this last swap time, both for now in milliseconds, and if 60,000 milliseconds has passed, we tell our frame index to update, so increment it by 1. So we're going to the next frame within the list, and we check for the length of our list. So the background frames is the list that has all our images. We check that length, and we use the modulo operator to make sure our list kind of like wrap around. It never goes out of bounds. So let's say we're at the last item of our list. Instead of going one over, one out of bounds, so it's trying to go to the next item that doesn't exist, we just wrap around to the first item again. And then we just reset our swap time so we can compare for the next time it's time to update our background. Now let's create a function to draw our background. So here we have our function. Takes as argument the surface. What surface is going to be our game window when we pass it to our main file, so our main game. We're going to split, so we're going to draw. What are we going to draw? This list of images, but we can't draw a list. We need to draw a specific image within the list. So that's going to draw this specific frame we're currently in. And we're going to start from 0, 0, just the top left corner, 0x, 0y. Now let's go to our main file. Let's import from our background these two functions that we're going to need. So where we have our own modules below config. So remember, we always have to import config first because we initialize Pygame there. So from our background file, we'll import from that module our update background function and our draw scroll background. Now in our main game loop, so where we have our while loop, you can see here we have our config game window where we fill that black surface. So remember, we always first want to draw the black surface, and then we want to draw the image afterwards that we want to show. So we want to clear the screen, and then we want to show something. So we'll call our function. We'll pass delta. We'll create it just now. We'll call our draw scrolling background. Background isn't scrolling, but later on we might be able to do that. It depends. But that's the name for now I'm going to use for the function. Now let's say delta equals, and we have our frame rate of our game. And then we're going to divide it by 1,000.0 to get our game in milliseconds. And this will return when is the time for the next frame. Now, if in our background file we are importing from the wrong place, we have to first check for the image folder, and within the image folder is the background file, or folder, sorry. Now, it seems to be working, but the time is just takes 60 seconds. Let's see if we can make it less than a second. And to show you why the black background for each frame first is important, I've shifted the frame and I've commented the black surface out. So we're not drawing that black surface first, we're just drawing the frames and we're shifting them slightly to the right. You can see any moving object is basically smearing. So that's why we draw the black background first. So we clear the previous frame and then we draw from scratch, so from fresh. So you can see we get this smearing effect. And we do not have to do it for the main menu static image. It's not moving. So we can see we've added the black background for each frame that we draw again. It resets the screen surface that we've drawn on, and we get a single conclusive image. And we create a reset background function that resets our frame index and our last swap time and sets it to 0. It will allow us when the game ends, we just call this function and we start from the first frame again. Now let's go to our menu file. We'll import this reset function. So from our background module, we'll import this function. And then we'll call this function at the start of our menu. So we have our menu screen, which has variables and states before our while loop for our menu itself. So we're not going to do it in the loop itself. That was because we're doing it 60 or 30 times for this loop, but it's waste. We just have to do it once. We can see it resets if we exit the game. And we'll set the timer back to 60 seconds. We've reached the end of this video and the end of this lesson.